Hello there, Mr. Sutton with a lesson on inverse functions. In this one, we'll teach you how to find an inverse of a function if it exists, and as our real-life application, we can use this to decode secret messages. Now, many of you have been using inverse functions this whole time without even knowing it. Maybe you were typing a paper and you made a mistake, a big mistake. Maybe you erased something you didn't mean to, and then you pressed Control-Z, and you undid your mistake. That's basically what inverse functions do. So, like the force, mathematics is balanced with pairs of functions and operations that can undo each other. Take a sec, pause the video, and list out as many of these operations as you can think of. We'll just do one here to get you the juices flowing. Addition and subtraction. See if you can find others. Okay, let's see what you came up with. Now, a lot of people are going to come up with multiplication and division. That's a good one. There's also some people might come up with square root and square. Just to make it more general, you can have an nth root and an nth power, and those will undo each other. Later on this year, we'll see that sine and inverse sine or arcsine undo each other. In fact, all the trig functions have inverse functions. And logarithmic functions and exponential functions also undo each other. And there's one more that I'll list here just because it's kind of interesting. And that interesting example is x to the negative 1, the reciprocal function. If you basically flip a fraction upside down, undoing that means flipping it upside down again. So this one is actually its own inverse. Kind of neat. Now that we've gone through the basic idea of an inverse function, let's get an official definition. An inverse function, and we have this little -1 notation here. It's not an exponent, it's just bad notation. This undoes another function. If you give it the output, the y value, it's going to give you back whatever the input was, the x value. So it's basically switching all the x and y values of the original function. A good example of this is like this, looking up a cell phone number. So when you plug a name into your cell phone, it'll dial the number associated with that name for you. But sometimes when people call you, your cell phone looks at the number and does a reverse lookup to see what the name for that number was. Now, a one-to-one function is a function where every x value is giving you only one y value. So you don't have any repeat x's and y's. So, for example, with the cell phone, if you plug in somebody's name, two different names are not going to give you the same number, at least if you've only entered one number for every single name. Only one-to-one functions can have inverses. And if you think about why this is, an inverse is taking the y value and giving you back the x value that caused that y value. This is going to be tough to do if you have two different x values giving you the same y value. Because in that case, how would you know which x value to give back? So functions that give the same y value for different x values don't have inverses. We just don't know which original x value to return. And one thing that all of these non-inverse kind of functions have in common is that they fail the horizontal line test. If you have the same y value for two different x values, you basically have two different points on the same horizontal line. And that doesn't work for inverse functions. So some functions that fall into this category, we've got parabolas, x squared. We've got that v shape, the absolute value. We have those wavy functions, the sinusoidal functions, sine and cosine. And another good example, it's not the last and only example, but constant functions, horizontal lines, definitely fail the horizontal line test. These are all functions that give the same y value for a bunch of different x values. So again, you don't know which x value to give back. Okay, enough theory. We're going to do some actual problems now. For all of these, we're going to be figuring out what the inverse is, that's f inverse again, or we're going to figure out that there is no inverse. So the first thing we should be doing on each of these problems is asking, does this function have an inverse? And this is a linear function. This is going to pass the horizontal line test. So this one does. If it has an inverse, we're going to go ahead and remember I said that it switches all the x and y values when you take the inverse of something? Well, that's what we're going to do. We're going to replace x with y and replace y with x. So instead of writing, this is basically y out here, instead of writing y equals 5x plus 12, we're going to write x equals 5y plus 12. And then we're going to get the new y here all by itself. So first step to do that is subtract 12 from both sides. And then we're going to have to divide by 5. Now at the end, instead of writing y equals x minus 12 over 5, we're going to write f inverse instead of y. So f inverse equals x minus 12 over 5. Okay, here's a few more examples. Pause the video and try these ones on your own. All right, let's see what we came up with for this first one. So this is the square root function. You know from your function families, this has one of those R shapes, so it will pass the horizontal line test. Let's go ahead and switch x and y. So we've got x equals square root of y minus 1. Now to undo a square root, remember we have to square both sides of the equation. So that'll be x squared equals y minus 1. And then just add 1 to the other side for f inverse equals x squared plus 1. On to the next example. For this one, we have absolute value. Now, absolute value, remember, that's a V shape. That's going to fail the horizontal line test. So this one does not have an inverse. I mean, if you plug in negative and positive 1, you're going to get the same answer, so you wouldn't be able to backtrace that to figure out what you plugged in. Over here, this is a parabola. This will also fail the horizontal line test, so this also does not have an inverse. And if you ended up switching x and y and trying to solve for the inverse, you'd end up having something to the effect of f inverse equals plus or minus something with a square root. So that's not going to work for inverses. Here's another one with a few more steps in it. Try this one on your own first off. All right, let's first verify that this actually does have an inverse. The main function here is a 7th root. Now, all the roots are one-to-one functions. They all pass the horizontal line test. So let's go ahead and switch x and y on this one. So we've got x equals 7th root of 9 over 3y minus 5. In order to get the y out of here, we're going to have to raise both sides to the 7th power. So that'll be x to the 7th equals, well, all this stuff without the root. And then there's no easy way to get y out of the denominator here. We're going to multiply both sides by 3y minus 5. And in the same step, I'm going to divide both sides by x to the 7th. I'm basically going to switch this denominator with this x to the 7th. It's almost like cross-multiplying. Next, let's add 5. And finally, we'll divide everything by 3. That'll give us 3 over x to the 7th plus 5 over 3. For our wrap-up problem, we're going to use a practical application of inverse functions, cracking codes. Let's say that you ask Cody in your math class on a date. Before he or she can answer, Mr. Sutton informs you it's not a talking time. Cody slips you this note with his or her answer on it. Cody's kind of a gender-neutral name. So this is what you see on this piece of paper. You assume that these 4 numbers were created by taking 4 letters with numbers corresponding with them and plugging them into this function. If only there were a way to figure out the numbers that were originally plugged in. Now, I know you could kind of cheat and plug in every single number from 1 to 26 in here and match them with these, but let's be a little bit more creative and see if we can do this with inverses. So here's our task. Find the inverse of this, and then plug these 4 numbers in to see what the original numbers were and match those with letters from our table. Pause the video, take a sec to find the inverse, and we'll bring it back together. Okay, let's see what you came up with. So we have x equals 5th root of y cubed minus 100. 5th power for both sides. Add 100 to both sides. And then take the cube root of both sides finally to get y by itself. So there we have it. Now, there is a faster way. I mean, you could plug this into this function every single time and do like, this to the 5th power plus 100, cube root that, and do that 4 times. If you're going to be plugging a bunch of numbers into one of these functions, let me show you a quick way to do that on the calculator. So to do this, you're going to want to go to y equals, and you're going to want to actually type in the function, which let me just move this here. This was our function, cube root of x to the fifth plus 100. You can find the cube root function in the math menu here. It's the fourth option down. So you've got this plugged into y1, and now you're going to want to quit out of here. And in order to plug things into a function on the grapher, you need to go to the vars menu right here, this button. Go over to yvars, and then click on function, and then bring up y1 or whatever function you wrote the function in. And now you can treat this just like a function like f or g of x. You just have to put a little parentheses next to it and then plug the number in that you want to calculate. So for example, we want to do 6.890. Let's go ahead and punch those numbers in. Don't need a parentheses on the other end if this is the end of what you're doing. And that's about 25-ish. So that's the same thing as if you actually did all this manually. So go ahead and do that for the other three numbers. And one thing you can do to actually make things go a little faster, if you do second enter, it just brings up what you typed in before, and you can now just replace a piece of that instead of hunting for the y1 function all over again. Press enter, so that's about 5. Okay. Pause the video, do that for the other two numbers real quick. And let's see what you came up with. So I ended up with about 1 for that. It was like 0.98 and some change. Plugging in this last one, I got a number that was pretty close to 8. So matching up those numbers with letters now, we have 25. That's a Y. 5 matches up with E. 1 is A. And 8 is H. And you can create any code. You just have to write a function that you're going to use to encode things, and then somebody has to know how to take the inverse and look up things in your table here. So that's it for inverse functions. Until next time, this is Mr. Sutton signing off.